All right, so as we're looking at section 4, what we're going to have to do is now we're going to take ratios and proportions. We're going to start applying them to story problems, applying them to percent change, applying them to estimation, applying them to error systems and analysis, which is where we really start to get into the application ideas. So as we're starting here, one of the main ideas we talk about today is called percent of change. Now, my first scenario, you go into a store on one day and the price of a CD was $15.99. You go into the store the next day and the price of the CD is now $9.99. The question is, what does the big sign say in terms of the markdown? So what we're going to do to figure this out, we say the percent of change over 100 equals the amount of change divided by the original. And underline original there because the original is the key idea that you divide by. So here we have the CD going down in price from $15.99 to $9.99. So how much did it go down? Okay, it went down by $6. So we set up our percent of change. P over 100 equals $6, as Nate told us, divided by the original, which in this case is $15.99. Do a quick cross multiply. 1599p equals 600. Divide both sides by 1599 on your calculators. And I get P equals 37.523. It says to round to the nearest what? Nearest percent. So now we're going to kind of institute a new symbol, a squiggly equal sign, which means approximately. So rounding to the nearest percent, 38%. So P over 100, change over original. So this CD went down 38%. So if you're the guy who has to make the tags up and hang below the big display, you're going to mark 38% off. That's the deal. That's the break that these guys are getting. Now, the next day your boss comes in and says, "Hey, put the prices back up because we want to raise the price back up." So the question is, when you raise the price back up, does it go up by 38%? Let's see. All right. The change in price obviously is still $6. So we say P over 100 equals 6, but now what's the original price? Where did it start? $9.99. So put $9.99 in the bottom. Cross multiply again. 999p equals 600. Divide 600 by 999. I get 60.06006. So to the nearest percent, what's my percentage? 60. How is that possible? How can the price go down by 38% and back up by 60% and it be the same starting price? What do you think? What's the difference? What's causing that difference in percentage? Matt?
On the first one, the original price is bigger.
Yeah, the first one, our original price is much bigger. So what I'm trying to show you here, put this into practical nature. If you see a thing and it says 38% off, you think, okay, that's a pretty good percent break. If you say 60% up, wouldn't you think that's a larger increase than 38% off? And so you have to be careful as you're a consumer to understand percentages when you're going and doing shopping and analyzing stocks and saying, okay, Dylan, you're going out and we have the Dylan Enterprises and they go public and on their first day, their stock price is $1. Okay? They do an IPO and their first stock price day is $1. And everything goes crazy and Dylan's got a great marketing rep, and Justin goes out and publicizes this extremely well and shows the profit of the company and their great inventions that are coming out and the new contracts they have with the Navy to provide this little part that's going to go in the new airplane that every airplane is going to end up needing. So everybody needs this. So on day 2, their price goes up to $2. What percentage increase was it? It's 100%. Well, Dylan's company just blows the doors off. It's the new Apple of the world, and he is now the newest billionaire. And now his company, a couple years later, now the stock price is $145 a share. Justin is continuing to do this. Justin is looking sharp in his good-looking suits. The next day, the price goes from 145 to 146. Is that a 100% increase anymore? But it's the same $1 increase as it was 2 years ago. But now it's only 1/3%. So you have to pay attention to both the percentages and the numerical numbers as you're doing analysis of your work. So don't be deceived just by percentages. Also be smart enough to look at the real numbers. Okay? So, percent change. First idea. We've got a couple little snippets today in terms of little different ideas. All right, down at the bottom. Greatest possible error. When you guys are doing experiments and things like that, it's important to limit your errors by making as accurate as possible. So, one of my kids gets on the scale this morning, and the scale says 145.2 pounds. Now, you ever seen the scales that they like flicker back and forth between two numbers? All right? This scale flickers back and forth and ends up on the nearest tenth. Is it possible my son does not weigh exactly 145.2? But we know he could weigh maybe up to about a half more or a half less, right? In terms of a half of a tenth of a pound. And so we call the greatest possible error on this 0.05. All right? It's comparing its half of the decimal. Half of the decimal. So what I want to do is I just want to do a little table here for you in a little sec. After I'm going to do this second example at the bottom, we're going to do a bunch of examples over here to the side, so don't write over on that side. Next, I look at Luis, who stands up, and he looks like he's about 6 feet tall. And all I tell you is he's about 6 feet tall. Now the problem is I'm measuring him from back here. And the unit of measure I'm using is feet. So you know he's at least close to 6. And he's not close to 5 or 7. All right? That's all you know. Well, his greatest possible error is 1/2 of a foot. Because all I've told you is he's 6 foot. I told you nothing about his inches. So notice it's half of the most accurate measurement. The accurate measurement here, Zach, was units, ones, so it's half of a 1. So let me give you some measurements on the left and the greatest possible error on the right. And as you see these, raise your hand, and sooner, we'll all start to get this. I measure something and it's 0.03. The greatest possible error, 0.005. Half of the second decimal. Another one. I measure something else, it's 13.8. The greatest possible error is, somebody? This is tenths. What's half of a tenth? 0.05. 5 hundredths. All right, next one. The measurement is 25. What kind of units am I in? Single units, right? So the greatest possible error is 0.5. Nate, I think you got it. Who else feels I got it? Let me see. All right. Noah, I'll put you on the spot here. You okay? Measurement 14.72. Greatest possible error, Noah?
0.005.
Excellent. 0.005. 2 decimals here. The greatest possible error is 3 decimals. Who thinks they have it now? Okay, another one. 16.123. Who hasn't answered yet? What's my GPE? 0.0005. Here's the key. If there's 3 decimals here, there's 3 decimals here plus half of one more. Who still doesn't get it? Let me see. Who does not understand it? Let me see this. It's really simple. So we're all good? Gabe, you okay? All right, so last one. Here's the measurement. 700. Notice I rounded to the nearest 100. What's the GPE? If I tell you it's rounded to the nearest 100, then the GPE is 50. Because I told you it's rounded to the nearest what? 100. But if I just say the number is 701, then it's not rounded. What's the GPE now? 0.5. So it's just a way of being accurate. Does anyone know Brittany Birchie? All right, her father has a company with his father by the name of Camcraft. They make high-level accuracy nuts and bolts for the military. And it's laser done. It's all done with lasers. Very, very, very accurate. They have to turn out stuff that's extremely small accuracy. 0.05 would not be good enough for them. The military wants stuff that is absolutely precise. All right, flip her over.